All right. Thank you all for coming. So in this session, we're going to be talking about the integration technologies and patterns to help you be a little more successful long-term with the cloud. Got about a dozen demos queued up of all sorts of different technologies that highlight some of the most compelling things in the market today. So first, my name is Richard Schroeder. I'm a product manager for a cloud computing company, Tier 3, Microsoft MVP for integration, book author, trainer for Pluralsight, editor for InfoQ.com, and a couple other things. So I appreciate you guys coming out today. So I guess first off, I would suspect that this is the most terrifying / awesome time to be an application developer. I mean, sitting here with a credit card, you and I can right now go out and buy ERP systems, CRM systems, finance systems with a credit card and boot them right up. Like, that's unbelievable that we can all do that today. And companies are doing that. Forrester just did a survey that showed that most companies have at least 6 SaaS applications in production today. Same time for developers. I mean, we can right-click and deploy to production in the cloud in a matter of seconds versus begging and paying infrastructure to give us hardware. And developers are doing that as well, too. Forrester says that 1/3 of developers have now pushed an app to the public cloud. So it's out there. Everybody's deploying things. People are using the cloud pretty vigorously. So that's great. I guess the challenge is that it has never been easier to build complete application silos in the cloud. At least when you built those rogue apps on-premise, you were throwing Access apps out there or random ASP.NET apps, you still got to leverage some of the single sign-on stuff. You were on the network. You could hit network shares, maybe shared databases. I throw something up in the cloud. Inherently, I'm not integrated with anything. So it's really, really simple to create silos, and you're actually seeing that this has been a big problem, where integration is the leading cause for cloud project failure, because you deploy something, and all of a sudden you realize you've had to duplicate identities and data and application logic and all these sorts of things because your app isn't connected to anything. And so it's great when you first get started, and it's great that your marketing department decides to spin up a CRM system all by themselves, but inevitably they're going to come running back to IT because their app doesn't do anything outside of what that app lets it do. So this has been a big problem, and you actually have 3 completely new paradigms now. You've got ground to cloud, where you've got ground systems trying to talk to stuff you've deployed in the cloud. You've got cloud to cloud, where a couple of different software as a service or PaaS applications are trying to talk to each other. And then you've got cloud to ground, which is the trickiest and also kind of the coolest one, where you can have cloud systems that are talking to on-premise things. So these are really 3 new paradigms that we're faced with today. And hopefully I'm going to show you some ways to do all 3 of them. So the ideal end state is it really doesn't matter where any of your stuff is sitting, whether it's sitting in your data center, it's in a hosting provider, it's in a public cloud, it's in your private cloud. All of your stuff should be able to talk to each other regardless of its location. That's our ideal end state at this point. So what's different in the cloud? I'm going to call out a dozen quick things that are going to be a little different than what you have in your own data center. So latency's a little more of a factor. Instead of the sub-millisecond or 3 millisecond hop in between servers in your data center, you might be looking at 80 milliseconds to cross the country, or 200 if you're going over to Europe from the US. So factoring that in and realizing your user experience might not be as nice when you factor that in. You've got identity management. How are you proving who people are? What are they allowed to do? It's a little different when you might not have a shared repository everyone's accessing. You've also got different SLAs. You don't have a throat to choke necessarily when Azure goes down or AWS goes down or any cloud provider. You have a particular SLA that they provide. You've also got different data security requirements where you've got to potentially encrypt everything at rest because you don't know necessarily what server this thing is sitting on. How are you going to monitor things that are sitting across a dozen different cloud platforms? If something goes wrong, how in the world are you tracing where it belongs? Management at the same time. Can you do any sort of central configuration management, or does every single cloud app have its own thing? As you have mobile devices, you're going to have more usage. You're going to have some services that get beat up more than others. Interop, once you start working with cloud platforms, you can't dictate the technology underneath. You're often going to be subjected to whatever platform that thing supports. So a lot of your things have to be a little more interoperable than before. Changing schemas. If you're interfacing with a software as a service app that goes through a quarterly update, and maybe they change what properties are available on an account object or a customer, you've got to be ready for that. If you've got a lot of hard-coded expectations of a data model, you might be in for a surprise when you're dealing with cloud platforms to change their data models. You've got services, not servers. Often when you're doing platform as a service, you have absolutely no idea what servers you're talking to, where they're at, what their configuration is. So you're talking through web service endpoints. You can't run a scheduled task on the server. You can't do things and terminal into the machine. So cloud platforms, you treat more things like services than individual servers. Connectivity, I mean, how are you going to handle if that service does happen to go offline? I know it makes all the biggest news when Azure or AWS or Rackspace or these companies experience an outage. Arguably, they have better SLAs than most of us have in our data centers. But how are you handling it when it just is offline? Does your app completely grind to a halt, or do you have some sort of ways that you can get around that? And then finally, things being very REST-based. So if you're dealing with a very SOAP-based web services culture, it is harder and harder to find public software as a service platforms that are embracing SOAP. You're seeing some of these actually start to deprecate that. So being at least familiar with some of these REST principles are going to help you out in cloud apps. So with that said, I'm going to walk you through 4 things, the 4 critical aspects of cloud integration I would propose. How do you integrate apps? How do you integrate data? How do you integrate the identity? And how do you integrate the network? And each one I'll show some different technologies, some from Microsoft, a couple not from Microsoft. I don't think I'll get stormed for showing those. You'll defend me. I think we can show that off. So first, application integration. What are we talking about with app integration? We're talking about functionally connecting apps, often sharing small pieces of information between systems, often synchronous kind of request response, at least that's RPC, remote procedure calls. This is something we're all very familiar with, right? You query a service, you get something back. This is what you're going to often use if you have a bunch of independently built apps who expose some sort of interface or contract, and you want to link them together. So again, this is often synchronous. The data stays with the source if you're just querying it, so it's good, very service-oriented when you see that pattern come into play. You often don't need a message bus in the middle, or sometimes you don't, because if you get an error, you just try it again. So you don't need a reliable messaging engine in the middle. But what are some of the challenges as you look at remote procedure calls in the cloud? Well, you've got things like coupling. You might be very coupled time-based to that service. What if that service goes offline or the load really picks up? You're kind of coupled to the availability of that service. You've got very HTTP-oriented for most of the cloud-based services on these systems, so you're not going to talk TCP to these. You're going to talk straight port 80 for most of them, or 443. Latency is going to be a factor. If you're going over the cloud and you're used to just calling a bunch of services and apps in your data center, and now you're calling them in public software as a service apps, it's going to be a little slower. The network access, how are you opening up the ports? Do you have permissions to do that sort of thing? Is it going to scale well? RPC doesn't always scale great. If you start pummeling it with a bunch of callers, is that going to work well? Transactions, again, can I scale transactions across these multiple servers, or should I try to design these a little bit differently? And then hiding the network is one of the biggest complaints with RPC is so many of these great client tools. I mean, if I'm in Visual Studio, I can just add a service reference, and it gives me a great little proxy, and I have no idea I'm going over HTTP, right? It just feels like a local object. But if that local object is really calling something that's halfway around the world, I don't know if I want to hide that. I want to make people feel like they're calling things over HTTP so that they factor in latency and they factor in that aspect. So hiding the network can be dangerous. So let me show you the first demonstration. So let's assuming I'm using Salesforce.com, boo, hiss. I know Dynamics CRM is everyone's favorite here, but let's assume that you are also using one of the industry-leading CRM platforms, and you're on an on-premise system. And maybe you have a dashboard where you want to see opportunities and accounts, multiple data objects sitting up in Salesforce.com. One thing you can do is use something like an integration bus. Let's say I want to combine the results from that so that my on-premise system simply queries that. BizTalk goes ahead and calls Salesforce.com, calls multiple different objects, gets it all back, smashes it all together, and then sends it back to the dashboard that the client is looking at. Ambitious. Let's see if we can get the first demo working. All right, so we'll start off here in Visual Studio. And so what I want to show you first is I have a web page that's going to retrieve data from this Salesforce service. So I've exposed a service from BizTalk server, and then my web page is simply going to query that. So my web page only knows about this proxy object. It has no idea it's calling Salesforce, which who knows where the servers are necessarily going to be for my instance. It's just going to simply call them, and there's a little function that calls, submit a query. So again, this can be dangerous if I don't realize I'm making expensive calls across the public internet, but nonetheless, this is the way this works. Next, let's look in the BizTalk project. So if you're not familiar with BizTalk Server, it's Microsoft's integration bus, and one thing that you can do is you define messages that define the format, schemas, and then you also define an orchestration, which is a workflow, an executable model, if you will. So in this executable model, what I'm first doing is modeling a synchronous experience from my caller. So my caller is making a synchronous request. I'm receiving that query. I'm calling Salesforce.com. I'm saying, give me all the accounts you've got. I'm getting it back. Then I'm querying Salesforce again, saying, give me all the opportunities you have that match my criteria. I'm getting that back. I'm smashing it all together into one response object, and then I'm sending that back to the caller. So this is this typical stuff that you pay those integration guys in the corner to work on during the days, and they can pull these together for you. And I can smash together these maps, and I can look at the data coming back from Salesforce, opportunities and queries, and smash it all together into one response. So this is a pretty handy way to deploy integration solutions. So if I've got that, then I deploy that to a server. And the way it works is that in this server, I'm configuring access to Salesforce.com from BizTalk. And I can securely invoke Salesforce operations. It requires a token, so I've even written a little custom behavior. But as you can see, there's nothing up my sleeve. I am calling Salesforce.com to get this data. And I'm able to configure that very easily. I don't have to write any code to make that happen. Those things just work. I'm calling Salesforce. I'm making a REST-based call. I'm using a REST adapter. I'm doing a GET. And I'm actually able to execute a query in the URL that gives me my accounts back. So I've got this running. Let's go ahead and see that in action. And to prove I've got some data in Salesforce, I've got some various accounts in my system. I've got various opportunities in my system. And what I'm hoping is that the web page I've built is going to be able to query those and get those back. Let's go ahead and check that out. So I'm going to query that. Hopefully it's relatively quick to get that data. First it authenticates, and it gets a token and gets data, smashes it together. Hopefully gives me back a list of a handful of accounts and then a handful of opportunities. So that went through BizTalk Server, which went to Salesforce, got data, smashed it together. The cloudy way you might want to handle this as well is maybe this might take a few seconds. So do you want the user sitting there waiting while their browser is processing? Or do you want a different way to handle that? So what I've also done is, I don't know if anyone here has ever used SignalR or heard of that. It's a really cool technology. Actually, it's magic technology. I don't even know how it works. It's WebSockets, but it lets you push from a server to a client browser. So not client to server, it's server says, I'm going to hit that browser instance or that browser instance and push data to it. So it's a really cool interactive way to do data transmission from server to client. So let's say instead, you might model this to be more cloud friendly and say, when I call this service, I'm going to do it asynchronously. So I'm going to call it and my connection's done and I can be back on the page. Meanwhile, I'm going to, in parallel, query for accounts in Salesforce and then query for opportunities in Salesforce. And then when I get each one back, I'm going to independently push it back to the browser. So then if this one takes a second longer than this one, who cares? The client is just getting these things popping in on the screen. So this is how Gmail works or Hotmail works. I mean, it's all this Ajax behind the scenes stuff. I see no reason you can't bake this into your enterprise integration solutions too for a more interactive experience, especially if you're talking to cloud endpoints that might be a little slower to process. So on the client side, for this to work, it's really quite straightforward. The little async page that works has a bunch of JavaScript. And this is a function I define in JavaScript on my web page. This is sitting in the client's browser. And this is the one that the server is going to invoke. So when the server's ready, it calls this function on my browser instance, which sends in the data and writes it into a table. I don't know. That stuff's magic to me. I love it. It's great. So let's see how that works. So on this one's asynchronous. And so when I query this time, I think it's going to be fast enough where it's going to come in at the same time. But in essence, it's calling it, and again, there's no page refresh or anything like that. As soon as it was ready, the data gets pushed to my browser instance. So in this case, I'm doing RPC, I'm doing remote procedure calls, but I'm trying to do it as cloudy as possible by distributing it in parallel and even doing Ajax-y stuff to push it back to my browser, so it's a little better of an experience. One demo down, 11 to go. I like our chances here. So that was the first one. Next up, let's talk about the second demo. So in this case, how do I talk on premises? So since I jumped ahead of myself, let's say I've got a line of business system. You've got an ERP system, a finance system, HR system, whatever. And you've got some person floating around on the public internet who is supposed to be able to access that system. How do I expose that? Well, what do we do today? We throw it up in the DMZ, we give them VPN access, we do all sorts of ways to expose data, maybe even put a cache of that data in the public cloud. What you can also do is use the Windows Azure Service Bus, which is, again, probably the least talked about and most fascinating part of Azure that nobody else has, which is a way to do really sophisticated messaging, including exposing on-premises services to a public relay. So in this case, when I make it a call to the service bus relay, it tunnels through the firewall, calls the service sitting on my desktop, calls the line of business system, returns it, and returns it to the public internet. Now this happens before InfoSec people start throwing stuff at you that this is terrifying. What it actually is doing is opening up a bidirectional socket with Windows Azure so that it can send and receive data over it. So if you have pretty much any basic ports open within your network, you can use the service bus to expose very selectively certain things. Let's take a look at that in action. So what I did is I used the workflow service to model out an experience of calling a line of business system. So Windows Workflow is a nice little way to graphically build executable models. And there's also some more tooling to help you talk to things like SAP, Siebel, Oracle, and SQL Server, and auto-generate some of the objects you need. So in this case, I have a little visual model, and Workflow comes with all sorts of shapes that you can use to draw these models out and make really neat little flowcharts and fun things like that. The difference with doing Visio and then trying to do this is Visio you can't execute. This is the executable model. This pictorial is what actually the server runs. So in this case, as you can see, I've got these little shapes for selecting system. Where did that come from? Workflow lets you talk to line of business systems. I just installed the SQL adapter, but it does talk to Siebel, Oracle, and SAP. And you can simply browse a line of business system. So imagine if you're SAP, you can browse BAPIs and RFCs. If you're doing Oracle, you can browse tables and so forth. And it lets you simply connect to a source, see all the artifacts available in that source, like tables in this case, and choose which operation you want to run. So in this case, I'm graphically, again, not writing a lick of code to be able to talk to a database. Once I'm doing that, I'm returning that as a result. So this is an executable model. But the magic that I've baked into this is that instead of this just running on my web server, and I'll make sure you're able to, oh, that's terrible. Let's use our good friend Zoom it. Make sure you can see that I'm not faking it. So that's using seroter.servicebus.windows.net. That's on the public internet. So when this service starts, it will talk to Azure, say, I'm registering this address. It's my DNS, my namespace in the cloud. It'll connect to that. And now when anybody calls that URL, it's going to tunnel it back, call the service on my machine, this workflow, and return a result. And you can do this securely, making sure they're providing tokens, or you can even open it up anonymously if you'd like. So I did that. So once I start this thing, this will be connected up to the public internet. Now to prove right now that it's not, if you look at seroter.servicebus.windows.net, you'll see it shouldn't list it here. It just lists, this shows my registry of services I've got on the public cloud. Right now, nothing there. So let's go ahead and make sure that thing is on the public cloud. So we'll make sure my on-premise workflow is started here in IIS. Yes, we'll start the application pool as well. And just to make sure it triggers that connection up to Azure, I'm just going to browse the local version. And once that loads, it should also now be in the registry. So if I come back to here and refresh, sure enough, so now it's telling me here's a service in Windows Azure that talks to my machine. So let's see that in action. Now that's talking to a database table. Let's just quickly see what's in that inventory database table so that I can query something that's actually relevant. So I've got a bunch of parts, things like that. So that's what's querying. You're sending in a part ID, and it's going to give me back one of these entries. So let's look at that web page. I've deployed it to Windows Azure so that it's not testing locally. And so if you'll notice, this is a URL up on azurewebsites.net. This is using Windows Azure Websites. So this is sitting there on the public cloud, natively, no connection to whatever's on my machine. So let's go pick one of those part numbers, say 700. You've got to apply a part number first before you click buttons. Let's do 700, look up the inventory, and this should be now calling the service on my machine and returning the result. And it did. Now you can say, you hard-coded that, you don't trust me yet, we've only known each other for 15 minutes. Let's come back here and say that was 35. I'd ask you to pick a number, but then you might think I've just planted someone in the audience, so let's try that again. 49, and sure enough, that's 49. So that's querying my machine live. I mean, imagine taking your line of business systems and not giving your partners VPN access or giving them whole copies of data, just selectively letting them query a web service against your line of business system to get their data live. It's a really, really powerful concept instead of making you replicate content or overshare your security permissions. So that's another way of doing RPC from cloud to ground. Next up, let's talk about asynchronous messaging. So asynchronous messaging is transferring bits of data frequently, immediately, reliably, asynchronously between systems. It's the opposite of doing synchronous stuff. So this is when you want to share data in a very responsive, scalable way. This is the pattern you're going to see people espouse the most when you're doing cloud integration if you can. It's great because it's non-blocking. I'm throwing something out there. If I need a response, maybe I get a call back later, or else I pull something and query it later. But I'm not tying my source system to my destination. I've decoupled as much as possible. I mean, we do this mostly in everyday life. You go order a coffee, you give someone your money, you step back, they do the rest of their stuff, and then eventually someone calls you and says your coffee's ready. It's not synchronous. Same with sending email. I mean, if Outlook actually did wait for someone else to read your email to continue, I know it feels like that, that would be a terrible experience, right? The email just goes off, eventually someone reads it, it's asynchronous. So that's how we do a lot of our stuff. Now you'll also see messaging engines baked into this where you do real durable messaging, things like BizTalk that let you send one message in and fan it out to 30 people. Those are really useful scenarios as well where you introduce a broker. So what are some challenges with messaging? You've got some stuff like where do you want to put the intermediary? Should I pull or push? If I stick it on premises, maybe I have to let people pull it or push it. So you have to think about what's the right appropriate way to interface with a messaging engine. Limited support. You're not going to find a whole lot of software as a service products that let you do asynchronous queries, let alone push out asynchronous messages. The network access, again, how do you give the right security? Eventual consistency is a phrase you'll often hear around this in general, is that you're not immediately updating whatever that downstream system is. There may be a lag of milliseconds or hours or days. You just have to expect the fact that your source and your destination may not stay in sync at all times. And there can be provider limits. If you look at some of the cloud-based queues, some of them only let you query so many times per hour. So you just can't write a loop that queries your cloud queue every second and expect that to work okay. You'll get throttled back. So you've got to think a little differently than how you might do this on premises. I got a couple more demonstrations for you. So this first one's going to be showing off a few different technologies. Bless you. I've got Windows Azure Websites on the left. I'm going to have an app deployed there. And let's say I'm creating orders. And based on what the product you're ordering it is, I want to send it to one of 3 queues for one of my 3 providers. I don't want them all to get it. I just want the one who's supposed to get it. So I've deployed one of them to the Cloud Foundry platform as a service from VMware, now Pivotal, where you can deploy multiple languages to that platform. Now, how do I do this? I've got 2 choices, right? I could decide to hard code that logic in my website that say, if you ordered this product, send it to this queue, this product, this queue, this product, this queue. That's a lot of coupling. I don't know if that's a great idea. So what you can do is use the product that Microsoft announced on Monday, which is the Windows Azure BizTalk services. Now, they share a name. They don't really share a whole lot of common technology between the BizTalk I showed you, but this is messaging engine in the cloud, where I can model these sort of pub-sub scenarios, and I can do transformations. I can handle different file formats. It's a really powerful way to have a cloud-based integration broker. So what I'm going to do here is I'm going to send the message from the website to the BizTalk services. BizTalk services is going to figure out, should it go to this guy, or should it go to one of the other ones? And that's going to be their job. So let's go ahead and take a look at that in action. So first off, I'll show you in the Azure portal. Start killing some of these. If I look at my messaging area, you'll see I've got 3 queues set up in my namespace, and they're going to be queues for creative lead partner A, partner B, and partner C. Right now, you can also see there's nothing in them. So once again, not faking it, there's no messages in the queues. So I want to be able to target each one of these representing a different partner. So I've got a Node.js application that I've deployed to Cloud Foundry that's going to listen to those queues. So specifically, I'm going to be able to click a button on a Node.js application, Node being JavaScript on the server, really interesting, powerful stuff. I'm going to invoke an operation, query data, and then show it on the page. What it's using, which is really neat, is Microsoft supports Node.js as well as Ruby and Java and PHP, all these languages that they provide SDKs for. So I can write a JavaScript app that still works with Windows Azure and simply receives queue message. So this works where this app will be the thing that pulls from the queue once it's got something there for it. Back in Visual Studio, I've got the Windows Azure website, but I've also have the workflow. So in this case, this is the project that I built that uses BizTalk services. So what you see here is you've got the idea of a bridge on the left, and this has a URL, so it's addressable. I can send a message to this bridge. And then based on rules that are associated with each of these lines, I have a filter action that says, in this case, very simple filter action. I can write a little more complicated things. But if the product ID is less than 100, I'll send it to A, between 100 and 200 B, and so forth to C. So I've just set up some simple routing rules. What's neat is you can set up mapping between these things. So this has a mapper similar to that BizTalk mapper, but actually more powerful. So it lets me do things like, I'm going to set a random ID on the order ID, a little token that just gives me a generated ID. I'll have a little shape that can set the date to today. I'm going to aggregate the first name and last name to the full name. And I'm going to write a little script that takes a product ID and include a little C# that based on the product ID, I'm going to set a product name in my destination. So there's all sorts of things you could do here. But again, this can be handy. When you've got stuff coming from one system in one format, you need to massage it a bit before it gets into the destination. So when this project's ready, it gets deployed up to Windows Azure. And you can see if I click on this, you get a URL, that this will be the URL I invoke to get to this bridge. And then finally, I have a simple little web page that calls it. So let's go ahead and see that web page in action. We've got the Azure piece. While that loads, we've got the Cloud Foundry piece. Both of these, again, with URLs in the public cloud. And this one in the public cloud on cloudfoundry.com. So what I want to do is I want to enter a new order, and I'll give it a product ID that I know will get it to QB, or else this demo is really bizarre because it doesn't work right. So we'll make sure we have the right product going to the right queue. We'll pick a quantity. Sure, we'll do 10. We'll pick a date. We'll pick a customer ID. We'll pick a person. And I'll go ahead and submit that to a queue. And hopefully very quickly I get a response saying this submitted to the queue. Now again, this app has no idea about who the consumer is. All I did was drop it to a queue. Anybody could pick this up. Sure enough, it's submitted to the queue. I've got that good. Let's prove it's there. So if I come back to here, let's refresh my queues view. Hopefully QB, sure enough, does have one message in there. So now, again, I might go away and come back later and pull this. It's a great part of messaging where the two systems don't need to even be online at the same time. I can be polling this at a later date. It's durable. So if I come to this app and I'm on retrieve order, sure enough, here it pulled that object for that person. It put a name in there for the product ID I sent in. It had a particular date ordered, which is today, because it timestamped that. So that was a pretty neat way. If I come back here, the queue should be empty, because it's a destructive read. Sure enough, the queue's empty. So by using an SDK for a completely different language, I can connect two apps in the cloud without ever going through an on-premises broker. It's a pretty powerful case as well for doing this sort of cross-platform secure messaging. The next demo is going to be pretty similar, but there's a key difference between the two. So this is the one we just saw. In this case, I've got each recipient wants to receive it. I've got multiple recipients. Queues don't work with multiple recipients. So if I'm sending it to a queue, only one person's getting it. That doesn't work if I want to make sure everybody can get something that's interesting to them. So in this case, what I want to do is I have an on-premises system. I've got a cloud system. They both want to get this message. Maybe it's a new customer signed up for a website. And we all know, we all register for 5 websites a year and unsubscribe from 1,000. So we know there's some weird ratio of when you sign up for stuff, they share your name with everybody. So let's say in this case, we signed up for something, they're sharing it with all their other properties so they can sign them up for things. I'm going to use the built-in adapter for the service bus with BizTalk. So I'm going to pull a message into BizTalk, and I'm also going to pull a copy into a website. So I've got a topic with 2 different subscribers. Each one of them wants to pull that message and do something with it. So this will be very similar to the one before, except now we're using topics instead of queues. So the code in my Node.js application is also talking to using the Azure SDK. In this case, it's receiving a subscription because topics have the idea of subscriptions. If we look in the Azure portal, you'll see topics are a different section. And I have a topic here. And within that customer sign-up topic, I'm going to have a pair of subscriptions here. So Department 1 and Department 2, hypothetically. Neither of them have a message right now. So I want each of these to get a message that they can pull at a later date. So we'll go ahead and send a message into this. I'm using the same 2 websites, in this case, just different pages in the website. And we're going to create a new customer. And we'll add that new customer. We'll submit that to a topic. So that should get populated in the topic. Sure enough, it got submitted to topic at this time. If I look back here and look at my subscriptions again, each of those subscriptions should have 1 message in the queue. So each one can pull these at different times. It's not like a traditional queue where one person grabs it and you're stuck. Each topic subscriber gets their own copy. So if I'm on this web page, I can go ahead and retrieve that customer. Sure enough, it pulls that off. My custom cloud app is able to pull that in. And if I look at this again, I'll see I only have 1 left for the one that didn't pick it up yet. If I look in the BizTalk side, I can see I can configure a receive location, as they call it, that uses the built-in messaging adapter, which points to my subscription. So it's pointing to the Department 2 subscription. And so all I have to do is configure this endpoint, turn it on, and it's constantly listening. I can integrate things in the cloud with my on-premises service bus really simply. So in this case, this is going to route it to a file. Let's make sure there's nothing on the file system right now, so you don't think I'm making that up either. So this is where it should drop a copy of whatever it picked from that topic. So if I come back here and start this thing up, I think everything else is started up, yep. We'll enable that. It's going to instantly start polling, and hopefully very, very quickly, it finds something in that subscription for that topic, routes it through the BizTalk bus, drops it on the file system, and we can take a look at that. That's the user and the email and the country that we set up there. Sure enough, we have a message. It should be from Mr. Bluth. Sure enough, it is. So really easy to hook in my cloud system with my on-premise system using a message bus and hook up 2 cloud systems by having them simply pull the API against things like queues and topics. Next up, let's talk about shared databases. So in this case, you can use a shared database pattern if you want multiple things to be using the same thing at the same time. You don't want to share files. Messaging might be too slow. I want everyone to be consistent at the same time. Everyone's working off the same data set. So I can use a shared database if I want everyone to access it at the source. So I might use this for reference data. You could use this for reporting data. You could potentially use this for transaction data, but you could hit into some problems with locks and transactions. But shared database can be a popular pattern if you're working with business data and you want your partners to be accessing the exact same thing at the exact same time. So there's clearly going to be some challenges with that. This is as coupled as you can get because now everyone's tied to the same database. Rarely can you buy a product off the shelf that lets you just swap out the database with someone else's, so the commercial support's going to be a little sketchy. Scalability can be tricky if you've got everyone using a shared disk sort of database versus a shared nothing database where you can really scale it out infinitely horizontally. Many cloud databases expose HTTP-only interfaces, so if you're trying to do things with traditional database ports, that might not work. There can be provider limits on what features are available or how much storage you can put there, how much bandwidth is available. So again, you have to factor that sort of thing in as well. So I'm going to show you a very simple demonstration, but hopefully it's a powerful concept, which is, let's say you've got that on-premises database and you've got partners that need a copy of it, or maybe it's very elastic and you have a hard time figuring out how much allocation to put for storage. It's very, very easy to stand up a Windows Azure SQL database and do literally nothing except change the connection string from your custom app to use the cloud database instead. So it's a really neat idea. If I've got other partners now that want to access that transactional data, I could give them read-only access to that database sitting in the cloud without opening up VPNs, without putting things in DMZs, just simply moving my database to the public cloud. So in this case, I created a Windows Azure SQL database over here under Databases. And this is more or less a full copy of SQL Server. There definitely are some limits. Not everything translates, so your mileage may vary. But for a lot of applications, this works really well. So I've got a demo DB in the cloud. And I can actually browse that from SQL Server, the server manager here. So I can connect to that server and manage it and work with it. And it's not going to like it because the firewall, because it has to recognize my IP address. So I can come in here and make sure that it recognizes this IP address. And yes, I can say, sure, add this to the firewall rules. This is a great way to make sure that my app is the only one that might have access to it if I choose to. If I come back here and connect again, that worked great because it recognizes my IP address and allows me to access the server. So it's not like you're throwing things out there on the public internet where everyone can interact with your database. There's still a lot of different controls that you can put into place so that you can have some control over who's accessing it. We'll try that one more time. I got 12 demos. If I can get 90%, I'm really in a good place there. All right, might not like my IP. Oh, look at me. It comes back. So here it is. Here's my database. I've got my demo DB in the cloud. So this is the same database. I put the same schema up there. So I've also got an object for interactions. Let's say these are interactions I have with my customers. So I want to share this with public internet consumers. Maybe I've got SaaS applications that pull this in so I can get a full 360 view of the customer, those sorts of things. So if I look in that thing right now, there should be nothing in that database, or that table, if you will. So I'm going to quickly select what's in that right now, just prove that it's empty. And what I'm going to do is simply switch my custom app to point to this instead. So in this case, sure enough, it's empty. If we open up a copy of the application that's pointing at the database, right now it's going to be pointing at a local copy that does have content in it. It should have 4 records in there. Sure enough, so it's got 4 records in the database. This is the one that's sitting on my SQL Server today. So if I look at my SQL Server, I've got one called Customer Interactions, and that's got 4 records in there. And so this is working perfectly fine locally. So let's say we want to quickly switch this over to using the public cloud database instead. The only thing I need to do in my application is switch my connection string. So here I'll look at my web config file. I don't have to change a line of code in the application itself. I'm just simply going to add the other connection string, save that, come back to my browser. If I refresh this local application sitting on my machine is now pulling data from the cloud. And of course, it's empty, as you would hope, for this demo to actually seem reasonable. So we'll quickly add some information. And it's a complaint. We'll grab a date. Not sure what the product was. Let's click Add Interaction. And this should add it to my cloud database. Now, this is pretty quick for accessing a database sitting up in Windows Azure. And sure enough, this is now data that's sitting there. We can confirm that by quickly looking at a script. And we can select all from there again, and sure enough, we have a new record. So this is sitting in the cloud database. So the only thing I had to do was redirect my connection string, and I'm instantly accessing a database that I could share with other software as a service apps, other partners, pretty easily. All right, so that was that. So let's talk about data integration. So data integration now is different than application integration, where you're kind of sharing bits of information between systems. In this case, you've got more of the, I'm sharing bulk data, I'm potentially doing it on a schedule, I'm using data quality exercises to do things like address standardization and data cleanup and things like that. So one of your first options is doing something like a file transfer, where I'm going to schedule something to run at certain intervals. I don't need real-time replication, it's not necessary. I can't access the source system, potentially, so I just have to get these big data extracts and share them with something else. And this also works if you have an endpoint your data warehouse. So you'd use things like file transfers to make that work. So there's going to be some challenges with file transfer in the cloud specifically. Can you work with somebody who has cloudy adapters, where I'm talking to cloud-based endpoints? There are a ton, of systems where I've got purely cloud-based data warehouses or software as a service apps that might not natively integrate with SSIS and existing tools you use on premise. You've got inherently the time delay, of course, is that you're not going to run these sort of things all the time. Bandwidth cost comes into play. Everybody makes it really cheap for you to copy data into the cloud, a little harder to suck it back out. So when you're thinking about that, that might play into what you're doing. There's a principle from a fellow named Dave McCrory about data gravity, which is where your data goes, all your apps seem to coalesce around that as well. So every cloud wants you to put their data in there. It's a little harder to pull it back out. Also, excess data sharing. So one of the big problems with this, and why people would hope that this sort of pattern would die, is that you inevitably transfer probably more data than necessary. You're making copies that can accidentally get lost or shared or so forth. So you're inevitably doing a little excess data sharing than you should. So what I'm going to show you next is an example of SQL data sync. So in this case, let's say I've got that SQL server in the cloud, and I'm pumping data into there, it's great, but I also do want to pull it on premises for analytics purposes. Maybe I want to copy it into other systems. So I want to do a really simple synchronization. How do I do that? There's actually a really cool tool that's baked into Windows Azure SQL that makes it really simple to copy data back and forth between cloud databases and on-premise databases. So in this case, when you look at SQL Azure, there's a dreaded preview, because it seems like everything's either preview or beta nowadays. So we'll go ahead and click the sync preview. And what this does is you do two things. You run a little agent on your desktop, and what that does is it creates a connection to the cloud. In this case, I have a little agent that recognizes the machine on my server here, and it knows that. And I can create a little agent and a group, and what I do is I define a sync group. And what this says, here's the two databases. Here's one that's in the cloud. Here's the one I have on premises. And I can define, how do I want to replicate? Do I want to make sure I only replicate from cloud to on-premise, or from on-premise to cloud, or both ways? And then I can also choose who wins in a conflict. So really easy to configure this stuff. And if I click sync, now we added one record, if you remember, to our cloud database for George Michael. We want to see that get copied on premises as well. So when I click sync, what it does is it actually triggers that job, where it's going to copy everything that's in my cloud database into my on-premises database, and now I'm going to have one copy of what's in there. So again, really handy. I can schedule these. So if I chose to, I can come over here and configure this to run at a particular interval. Maybe I run this every few hours. Maybe I run it every night. But it's a great way to make sure that I'm replicating data that doesn't have to be in sync at the exact same time. So really handy for that. So we'll give this just a moment to see if it'll synchronize that one record in a fast amount of time. Yeah, quick question. It's a great way to distract the slow processing time.
Does this agent have to sit on the database server, or can it sit on a server that can reach the database?
Yeah, good question if you didn't hear it. So does the agent have to run on the server of the database itself, or just a server that can access it? My understanding is it's just a data server that can access it. So as long as it's sitting there on some machine that can go ping the server and pull the data, you're good to go. So I'll give it just another second, otherwise you're going to have to trust me that it's synchronized. Here's going to be our local database again. We would expect to see a new row. Oh, look at us. There we go. George Michael showed up there. And so there it did. It pulled the data in. So again, really powerful thing. Instead of you having to kludge together some sort of app that copies data from here and there and open up firewall ports and all that sort of stuff, don't have to worry about that. Now the next scenario, that's potentially a little simplistic. Maybe you have data sitting in other databases. Maybe you've got additional quality things you need to run against that data, where a simple sync of field to field isn't good enough. So the next thing I'll show you is not a Microsoft technology, but I still think it's a really cool one, is that let's say you've got data sitting in Salesforce.com or Dynamics CRM or any of these platforms, and I want to pull that data into my local SQL Server database. Again, I'm doing analytics, I'm doing something interesting with it. I don't want to keep it locked into that software as a service platform. I want to pull it in. So a really cool platform is Informatica Cloud, which what this does is the metadata is stored in the cloud. So your ETL design, if you will, is stored in the cloud. But once again, an agent runs on your machine, so your data never passes through the public cloud. So the server on premises, which just needs access to the data sources, doesn't have to be on the data source, queries the Informatica Cloud, gets all the metadata, it runs the complex ETL job against the Salesforce in this case, and pulls it back. So it never routes through a public internet channel. You don't have to worry about someone has your data. But the agent is just kind of a dumb agent that's able to execute metadata somewhere else. So you're not running a full-fledged ETL tool and having to upgrade it and maintain it. You're using a cloud-based designer for designing ETLs. Let's take a quick look at that. I mean, it's pretty compelling if you could build an enterprise-class ETL in a matter of seconds and minutes, which is really what you're doing here. And the nice thing is that this has the adapters for cloud systems, whether it's Salesforce or Dynamics or so forth. Very easy to create data synchronization tasks between all sorts of systems. So in this case, I've built one from Salesforce to an accounts database on my machine. So I'm integrating from the cloud to my database. So I'm able to give it a name, of course, and then I'm picking a source. And in this case, I've configured the source to be salesforce.com. It interrogates it to tell me what my data might look like for this object. Same if you pick Dynamics, it would show you all the different custom and standard objects in Dynamics. Next up, you pick a target, and if you have a local database, and then you might have a local MySQL database that you're trying to populate from your public software as a service app, or an Oracle database, or a flat file, all those are valid sources and destinations in this model. So in this case, there's nothing in my local database, but once again, let's prove that. You're starting to trust me, but we might not be there yet. So let's see if there's anything there. So here's my Salesforce.com account database. Nothing in there. So that's my local database it's looking at right now through that agent. It's a little agent that sits here and runs on my machine. Not much to it. And next up, you start getting pretty sophisticated. So I can pick a row limit. How many rows am I executing? Is there a data filter? Do I only want to pull records for account where and again, this is interrogating the objects. So where the particular revenue is greater than this, copy them across. I can do that. Then I can do some sophisticated mapping, so I can do drag and drop. I can do auto matching. I can create different types and functions, so I might want to parse field or do data quality exercises. Some very sophisticated ETL. Might not be as powerful as what you're used to using on premises, but this is something you can really bang through pretty quickly to do some pretty aggressive ETL operations. And then finally, you can pick a frequency. So I don't have to run this on a schedule. Maybe I would run it on a schedule where it runs every day, every week, every hour, whatever it is. But then simply running it is a matter of either scheduling it, or in my case, I'll just tell it to run. And it should go ahead and it's talking to my agent on my machine. It's getting all its metadata, querying Salesforce, throwing it all in my SQL database, and I could schedule this to run every day, every hour, whatever I'd like. So let's hope this thing will run relatively quickly. It doesn't know how many rows yet, as it's still thinking. So it figures out there's 14 rows. It's already queried Salesforce at this point. It realizes there's 14 different accounts it wants to pull in. It may have already completed. Let's come back here and refresh. And sure enough, it sucked over 14 rows from Salesforce onto my machine in a matter of seconds. Again, designing that was really straightforward. So this is not the old days of taking weeks and months to have to build an ETL process, deploy it to a server. This is configure it in a web page, save it, and it's able to run. All right. So we got that one to run. That was Informatica doing data integration. Next up, identity integration. So this is another tricky one. I like to torture my boss by letting him know that if he fired me tomorrow, he has to turn off my access in 18 different systems because we are not using good single sign-on and federated identity. And I would suspect it's actually not shockingly different in a lot of your places if there's software as a service apps, local apps, a lot of places where you have usernames and passwords that get you into systems. And that's tough if you're asking every one of your new software as a service apps to do its own credentials and manage its own credentials. How can you get around that? So there's three patterns I'll quickly point out here. First is you can use a single set of credentials to access shared resources. So here's a single system ID, and everyone funnels through that system ID. We do this all the time for certain apps, right, where you've got application pool IDs and other things where you're impersonating an account. It's not bad. You're not going to use that everywhere because there's a few things that jump out with that. You can't audit it. Right? I have no idea who's actually doing things because it's all funneling through a system account. I can't really do authorization well unless I set up a bunch of different ones of these. If it leaks, I've got to reset the whole thing because everyone's using the same credentials. I can do least privilege, which I guess is a good thing, but again, you have a difficult time assigning different rights because everyone's acting like the same person. So there's some interesting things you could do here. Let's say you've got reference data on site, and you've got reference data sitting in your line of business system, and you have something in the cloud that needs to access it. Now, I showed you a flavor of this before with the service bus. I'll show you a little more of a sophisticated example here, where let's say from Salesforce, I want to query data in my system and show it on a page. So in this example, let's say you're an account rep and you only visit my company when we have cool things on the menu for the day. So we're going to expose our menu service so you can see what we've got on the menu, and then you plan to visit us or not. So I'm going to take that menu service, and they're going to query it, and we're going to get those results back, and it's going to show itself on a Salesforce page. So building these sort of services, in this case, I'm going to use a single service credential. I'm not going to ask that every Salesforce user authenticate themselves because it's not that mission critical of an app. It's not a big deal if I don't know who's invoking the menu service unless, I guess it's a rogue salesperson who keeps making this choice to only visit me with cool stuff on the menu. So in this case, we'll go ahead and take a look at a custom Salesforce page I built, which queries a local database or queries my local service. And all this does is it's able to use the public web service API to invoke the service bus. So it's invoking a web service located at Seroder Service Bus Windows.net menu rest. So I've built a web service, and in a moment I'm going to start it up, and that's going to use that same service bus technology to expose itself to the public internet so that anybody can call it, in this case, if they authenticate themselves. So let's go ahead and start that service up. Actually, first I'll show you what doesn't work, just so you believe me. The service isn't running, so I should get a gnarly error because I don't do exception handling because I'm an architect, not a developer. And sure enough, I get a null pointer exception. And so let's go ahead and start that service up. And we'll go ahead and run this as admin. And so we're going to start this up. I'll know it's connected. And once it's connected, it will also show up in that registry again. If I look at seroder.servicebus.windows.net, once it's online, I've added it to my registry. Sure enough, there's the menu service. So let's go ahead and invoke that from Salesforce. I'll see if I'm quick enough to see it get invoked. Sure enough, menu requested, and it returned it. So that's data from my local web service. This is running on my machine. And I could switch cafes and invoke different menus. And it's querying services on my machine. So it's not just custom apps that can consume things like the service bus. I can be baking line of business apps that are software as a service, and they're already packaged apps, but they have some little extension model that lets me sling custom code. And if I can make it work in Salesforce, I can make it work all over the place. So it's a really cool way to connect my software as a service app to something sitting on premise. I'm unlocking this data that you've been storing for how long and these systems you've invested in. I can now expose these to the public internet in a pretty cool way. So that's using a single credential. Now that might not be good enough because you do want to have some of that auditability or personalization. You want to be able to actually have users assigned to this. So the next option is to extend your directory. So you might extend your on-premise directory to the cloud, whether this is creating a cache or read-only replica sitting in Windows Azure Active Directory, whether you use something like ADFS to do some way of extending your directory to more users who are outside of your network. So this is a great way if you want to actually still use your Windows credentials all over the place. If I use something like ADFS from pretty much every single platform and language, I can query that. Now, again, things like Salesforce and Dynamic CRM let me use ADFS. I can write custom code that also validates my identity against ADFS. So let's go ahead and take a look at that in just a moment. Again, some of the challenges, at least with extending that directory, is there can be some latency, potentially, if I'm using ADFS. The load could jump out at you. If you've just exposed your internal AD to the public internet so that all your mobile clients and custom apps can authenticate, you might be beating up that box more than you expected. So you might have to expect to scale that thing out to handle the load. You do have a bigger attack surface, potentially, or exposing some identity information. Interoperability is going to be key because it might not just be ASP.NET apps that are talking to this. So in this demonstration, let's assume that I'm going to use Windows Azure Active Directory. I've set up a directory in the cloud. I've got a Windows Azure website that's going to authenticate users against that. So you can do Windows Azure Active Directory from a couple of places. I'll show you doing it from the Windows Azure portal. And under Windows Azure portal, there's options to go to directory. There we go. I've got my Active Directory. And so from here, I can add users. So I can add specific individual users if I want to. Now, I'm not getting the full role-based management. I'm not getting all that experience from this view. That stuff's capable, but I'm not getting this from this portal. But I can pretty quickly add users to the application. In this case, I've got a couple of folks here. You can set up directory integration. So if you do want to do a synchronization from on-premises, you can do a directory sync from your own AD and pull those users up here so that you can authenticate them directly against the cloud endpoint instead of pointing them on-premises. So in this case, what I want to do is authenticate against this repository. So if I jump back to a custom ASP.NET app I've written that's going to use Azure AD, one of the nice tools that got baked into Visual Studio 2012 is this identity and access menu here that lets you point to things like Active Directory, other locations, pull in the metadata, and do a lot of this without configuring it by hand, which, again, for someone like me, it just means it's not going to work because I can't get all the settings right. So in this case, I'm able to simply point it to Azure AD, Azure Websites.net. Here's the app that I'm going to be pointing it at. Here's the location that it told me of how to find it. So I got all this from the Windows Azure site. Once I do that, I don't really have to do anything. I'm now able to, as soon as the site starts up, it's going to redirect me, ask the user to log in, and I get back a bunch of claims. Claims are everything that tell me about the person. So in my code, which is very simple, all I'm doing is looking at all the claims about that person and showing them on the screen. So nothing sophisticated, but you can think of your app could use that information to say, you have access to this, or personalize it to that. So it's authentication, but it's giving me the information I need to also authorize. So in this case, let's start up that app. The cloud directory. And so it's hitting an Azure Websites URL. You'll notice first. Now when I get out of this, it's redirected me because it detected I wanted to use Windows Azure Active Directory to authenticate my users. So now I didn't have to do anything here. I didn't make this page. This is the page they provide. So I just provide that user's credentials. And when I rerun that, it went ahead and this is my custom app now. And you'll notice that it gave me all the claims I needed. It gave me the person's name, what's their email address, what tenant are they in, any other metadata attributes I had exposed, it would have shown that. So now my custom app can use this stuff. I didn't have to bake in my own authentication scheme, which is going to be inherently a bit error-prone and now duplicative if I do it myself. I get to use Windows Azure Active Directory, use them for resetting passwords, managing users. I don't want to touch that. Instead, just give me your authenticated claim set, and I'll authorize you based on that. So that can be a pretty powerful idea. The next option will be to use Active Directory Federation services. And so in this case, what I want to show you is if I'm extending the directory, but I don't want to use Windows Azure Active Directory. I don't know what's going on there. I'm more comfortable with ADFS. So in this case, I can take an AD box, install the ADFS extensions, and then expose that up to the public internet. What's also cool is that because it exposes so many interoperable endpoints, I can consume that from, again, a Java app, a Node app, a .NET app, all sitting out there on public cloud systems. So that's what I'll show you quickly here is I'll have a Node application that does that. I'll also show you my ADFS box. While I'm logging into my company VPN, since I'm not shilling my company, but I'll at least show you my server sitting there. Is I've got a server sitting in the Tier 3 cloud, and I've just installed Active Directory on it, and ADFS on it, just showing that your AD could be running anywhere. There's nothing, it doesn't have to be a Windows Azure box, doesn't have to be whatever. So I've provisioned a server in our cloud. I've got an IP, a public IP, Once my VPN's assigned, I can go ahead and terminal into that machine. And what we can look at is some of the quick ADFS configurations to see how in the world does my app talk to that. So there's an ADFS management experience where I can set up who are the relying parties, who are the parties who are calling this, so I can make sure only the people who are supposed to are able to request authentication. So you can see I also have AD installed on this server, and I have a bunch of users in there. And within ADFS, I've established trust relationships. Now, first of all, I've also exposed the right endpoints. There's a lot of open source libraries and things like that to consume some of these other endpoints, even if they're not calling from .NET code. And I've created a relying party for a Windows Azure application. This application is identified by this URL. So it's going to be, here's the URL, that when requests come from that URL, I'm going to trust them. And what am I going to send? So when I see people come from that URL, if I've authenticated you, I'm going to send you a few pieces of info back. I'm going to give you the user principal name. I'm going to give you a list of all the roles they're involved in. I'll give you their surname. So again, once again, my app could use this, authenticate the user, handle all the password stuff with ADFS, get back a list of all your Windows roles, and then make decisions about, you know what, you're a manager, you're allowed to see this, you're an employee, you're allowed to see this, however you want to do it. So let's go ahead and see me call that application. So this is an app, again, running in cloudfoundry.com, a public cloud app. We'll look at, here's that user, the r/rotor user. It's got a certain set of credentials. It's invoking, it's calling this, sending these credentials securely over to ADFS, hopefully validating that this person is who they say they are. If they are, it gives me back all the list of roles that this user is a part of. Oh, this is very exciting. And what's nice is that because this is not a cache, it's not like I'm doing a replica from on-premises to an Azure Active Directory one where there could be a lag. If I'm actually using ADFS, as soon as I add new groups, as soon as I invalidate your account, as soon as I add a new user, all that stuff's instantly reflected. So that's going to be a lot easier. I probably got the credentials wrong. Let's try that one more time. All right. If not, this is my one mulligan demo. Oh, look at me. So I got back. He's a senior manager, he's a domain user, and he's an EU user. Now again, to prove that fact I just made where I could change the groups if I need to, if I came into my Active Directory and said, you know what, for this user, let's also point out the fact that he's in the remote employees group because he's just been, hey, we're going to let him work from home, we trust him, and we're going to add him to that. As soon as I come back here and I sign back in again, I'm going to get that information. And so I can see that this guy's also in remote users, or remote employees, so I can use that information. So I'm getting that real-time sync between the systems, which is really going to be handy if you need that. If you want to do a read-only replica in Windows Azure, go for it. But if you want to have that real-time access, ADFS is a great choice for that. All right, I won't torture ourselves waiting for that to come back. Right. So that's that. If you're doing that sort of shared credential thing, you also have then what I just showed you, which is using ADFS to extend a directory. The third option is to establish a trust relationship with a third party. If you've got business partners, if you've got consumers, asking them to create yet another identity that you're going to store in your AD or you're going to store in some other system is asking a lot, no? I mean, how many passwords do we all have? It's nice to be able to reuse a trusted third-party provider. So there's going to be some challenges there if you're using that model. Can you verify? The only thing I can verify with a trusted third party, let's say I'm using your Google ID, your Facebook ID, your Live ID, the only thing I can prove is that you're those credentials. I mean, I can sign up for an account that says I'm anybody. So the only thing I'm proving when I'm logging in is I'm those credentials, not that I'm that person. So I'm not able to verify the identity the same way. Management can be tricky because I'm not really getting a view into all the credentials sitting all over the place. I've got different SLAs. I'm using other people to authenticate my users. Hopefully that mechanism is available to me. So in this demonstration, what I'm going to show you is ACS, Windows Azure Access Control Service, works out of the box with a number of providers, including ADFS, but it works with Yahoo identities, Google identities, Facebook identities, Live identities. Without you doing anything in your code, you can instantly add these as authentication schemes for your app, which is a pretty powerful concept. So if we look at what that looks like, ADA, the service bus settings. If we go to wherever service bus is, actually I think I did that under ACS, you can actually set up the settings for which identity providers to support. So let's jump back. And I think it's under Active Directory or it's under Identity, one of these. There we go, service bus, namespace, that's fine. So what it is you're able to pick which of the identity providers you want to support. So what I'm doing in my code, we'll just jump to that, is if I jump back to here, to Web IDP, that same identity and access menu I showed you, I can point that to ADFS and pull in metadata, or I can give it my ACS credentials, my Access Control Service credentials, and it'll tell me which providers do I want to support. And you can also do Facebook if you set up for an application remote. So here, I'm choosing that I want to let users authenticate using a Live ID, a Yahoo ID, or a Google ID when they hit my app. Nothing in my application is specific to any of these. So simply by going to this menu and choosing these options, it updates my configuration file with a bunch of stuff that just makes it all work. I don't have to worry about necessarily baking that in. All my code has to do is all I'm going to do is get back again, who am I? And I'm going to bind to all the different claims that come back from that provider. So whatever you tell me about you, I'll be able to get that back. So if we look at what that looks like, oh, I closed my file system. Well done. So if we look at that application, it's going to automatically redirect me again. Now again, I didn't build this page. I can customize this page. They actually give you a little control over the look and feel. But it automatically redirected me to this. So when I pick any of these, it's going to go log me in. It'll prompt me if it needs to. And it'll return credentials about my Google account. And so I'm instantly getting that stuff back. Once again, I can use this to provide then mapping from this to roles in my application specifically. But if I need to change my password, I want to do anything else, my app doesn't have to worry about it. I'm using a trusted third party to maintain these identities. All I have to do is let you authenticate, and then I'll authorize you using whatever scheme I want to do. The final area of focus, so we've covered application integration when I'm trying to functionally link applications. We've got data integration when I've got to share blocks of data between systems. Finally, we've got network integration after identity integration. So how am I connecting two networks so that I can truly do system-to-system integration? Now, you might say, I'm never going to use the public cloud. This Azure stuff is madness. You still may find yourself wanting to set this up. So even if you're doing dev test in the cloud, some of the announcements on Monday from Scott Guthrie and team were making it easier to use dev and test in the cloud. But to do that well, the apps you push for dev and test probably need to connect back to stuff on premises, or else you have to replicate your entire topology in the public cloud. So even if you're never going to push a production app to the cloud, odds are you'd want to set up some virtual networking with a cloud provider so you can do legitimate dev test scenarios. One of the options is using point-to-site, and this is supported now in Windows Azure, where you can have an individual machine connect to a network in the cloud. So this is great for kind of desktop VPN scenarios when I want to connect my machine to something outside there. There's going to be some challenges with point-to-site VPN. There could be some performance stuff. This is going over the public internet. So if you don't have a fantastic public internet connection, it's going to be a little spotty. This might not be usable everywhere if certain ports have been closed that you want to use for VPN access. You do need a little bit of end-user savvy to set up the VPN and the configuration, and the customer's paying for bandwidth. So again, it's not a free and easy thing, but you are opening up a secure network connection. In this demonstration, what I'm going to show you is the Windows Azure Virtual Networking. So what this does is I can do it point-to-site in this example, where I want to connect my machine up to a virtual network I defined in Windows Azure. I want to be able to do this because I don't want to expose my virtual server sitting in Windows Azure to the public internet. I only want to expose it to me as a user. So if I come down here in Windows Azure, you can create virtual networks. And you can create some pretty sophisticated topologies with subnets and define what the IP ranges are and all that sort of thing. So you can define all this. And I've set this up with a gateway that I want to define a VPN. It lets you download the VPN package once you've configured everything. So I have a server that I've added to this network. This server is on that virtual network. And if you'll notice, if I look at this server, by default, when you stand up one of these servers, the RDP port's open. There's another PowerShell TCP port open. I've killed all the endpoints. So this thing has no public internet addressable IP address. There's no way I'm able to access it just from the public internet. I can't RDP in. Got the yellow light of death over here. All right. So what I have is I have an internal IP address. So I want to connect the internal IP. So what I can do is download that VPN package. It installs a private network connection that I can execute. I can connect to that. And what that's doing is now that's giving me a VPN connection to the virtual network I just created in Windows Azure. So now I can actually hit that private IP address that I've just defined right here. And now I can privately RDP into that box. So I can make sure that public users can't go hit that box. Only users who install the client VPN can hit that box. So a really cool way to now extend that cloud network and make sure I'm securing things. So now I'm hitting my Azure server using a private IP address that's not internet addressable. So that's one option. You also have site-to-site. This is going to be a little more realistic for most companies trying to set up a persistent connection. In a site-to-site scenario, this is when I want to have a durable connection that everybody at this site can talk to everybody at this site and create a durable link. This is going to work well in most cases, but once again, you are dealing with more complexity. You might have to set up some hardware and software. You're going to pay for bandwidth. It's going over the public internet again, so you could have some performance variability and latency as well. So the final option, Azure doesn't have this yet, but some providers like we do a direct connect. And this is if you want to do a cross-connect, literally link the cages in a shared data center, or if you want to do an MPLS mesh and attach to that. It's really a nice way to actually deeply integrate two networks. There's going to be some downsides there where you could have some vendor lock-in because you're signing contracts and things. Setup time takes a little bit more, but you're not going over the public internet, so it's extreme low latency and very high performing. So I showed you a lot of stuff. Hopefully it was mildly interesting, but the real takeaway is that all these things are established patterns. You just have to think about them sometimes a little differently in the cloud. There's different considerations when you're factoring in the latency and the bandwidth and identity and so forth, but the same patterns are there. Just factor in those differences. Thank you. I'll jump to the Scanny one if you need to scan for evals. I'll also be up here if you have any questions. But I appreciate you taking a look and hope you're inspired to at least try out some of these technologies and see what's there.